Okay, so this video is to give people help on problem 197 and specifically about B and D. And so again, this video can help you on these problems, but it can also just help you try to understand rotating a figure on a graph just in general. And I think it'll help you perform rotations on many, many future problems as well. And so mostly I want to talk about problem D, just because I think there's a little bit more complications on that one. And so we'll get to talk about a little bit more things. But I want to start with at least going over in general what this means here. And so when you have a figure that you want to rotate, you're going to be told to rotate a certain amount. And so that's what you see when you see like 90 degrees or 180 degrees. And you can see other just different degree measures depending on what the problem is. But then you're also going to be told a direction. And so that's what clockwise here means. And you'll see clockwise, which we call CW, and you'll also see counterclockwise, which we would call CCW, counterclockwise. And really what I just want you to know about that is it literally is based off of numbers on a clock and how a clock works. So if we have a clock here, right, and we got like 12, 1, 2, 3, 4, and so on, right, the hands on the clock go kind of this direction normally, right? They'll start at like 12 and then they'll go towards the 1, then the 2, then the 3, and so on. And so that's how a clock normally rotates. And so we call that clockwise. Clockwise means going the same direction that a clock rotates. Now, if you go the other way, starting with the 12 and then going to the 11, the 10, the 9, and going in reverse, we would call that counterclockwise, counterclockwise. And so if you go in the normal direction of the clock, that is clockwise. If we go in the opposite direction of the clock, that is counterclockwise. And so in this problem B here, it says rotate the figure 90 degrees clockwise. And so clockwise means we'll go this way. And then 90 degrees is like a quarter turn, right? Because if you go 90, then 90 again, then another 90, and then a fourth 90, you've hit 360, which is the full turn. 180 would be half of a full turn, and so 90 is just a quarter turn. Now, I want to talk more about actually doing that now here down in problem D. And so notice, this time they say rotate the figure 180 degrees, but it does not say clockwise or counterclockwise. And the reason is, if you can think of like a clock, right? If you go 180 degrees would be a half turn. And so if you go around the clock clockwise 180 degrees or halfway around it, or if you go counterclockwise 180 degrees, you still fall in the exact same spot, right? 180 degrees brings you halfway around no matter which direction you go. And so that's why in problem D, they have not specified that. It doesn't say clockwise. It doesn't say counterclockwise. That's because it doesn't matter, because 180 in both directions brings you to the same spot. So you can kind of pick and choose here. Now, let's get to actually doing this problem. And so one of the things you normally want to look for before you begin any of these transformation problems are like corners in our shapes, because these shapes that we want to rotate or reflect or translate, really they make up of points. And if we just move all the points, and then once we move the points, we can connect the dots again, we'll have rotated the full shape. Right? And so I'm going to put dots in all 5 corners, and those are the corners that I'm going to work with here to rotate. And then once I do it to all 5, I can just reconnect the dots and my shape will have been rotated. And so here's kind of how we're going to go about that. From my point Q, which is where they want me to start, or that's where they want us to base this rotation around, I'm going to make some L's until I hit my dots. And so I'm going to start and do it one at a time. So from that Q, I went left 1 and then up 2 to be able to hit that dot. Now, the reason we want to make these L's, as you kind of see in that one, but really you just want to follow our grid lines over and up or over and down, until you hit a dot. And the reason we want to do that is because as we start to think about rotations, 90 degrees or 180 degrees, it makes it easier to visualize rotating if we see these perfectly horizontal and perfectly vertical lines. And then those will be what we think about rotating, and where those go, that's where we'll be able to put our dot. And so let me show you about that. We are going to do two different rotations here in order to rotate this thing 90 or 180 degrees. We are going to do a 90-degree rotation and then another 90-degree rotation. If we do two 90-degree rotations, it's going to equal 180, right? Because 90 plus 90 is 180. And so we are going to do this by doing two 90-degree rotations. And so let's do my first one. And so really what you want to think about is you want to think about this line, these two lines we put here. You want to think about turning them 90 degrees. And what happens as you turn these lines 90 degrees? And basically what happens is all horizontal lines, that's this one, if you rotate it 90 degrees, and we're just going to go in the counterclockwise direction here, it'll go from horizontal to vertical. And so that little green line will now work to match up to this little orange line. It will have turned 90 degrees and it was horizontal, and now it's vertical. And then the same kind of thing happens with our longer 2-unit line here. It's going straight up and down now, but as we rotate it and as this green starts to line up with the new orange one, that part will now look like that, 2 units that way. And so again, in your mind, you want to try to imagine, and I'll try to clean this up a little bit here, this 90-degree rotation. So if you look at the green line first, that's kind of where it was originally connected. And if we rotate this thing down 90 degrees, it will reline up, or it will line up with where I've drawn my orange kind of L shape, right? And so that's kind of how it will rotate 90 degrees. And then we want to do it one more time, right? Because we need to do two 90-degree rotations. And so the orange was one, and now let's rotate the orange one 90 more degrees. And when we do that, it'll go into this position right here, right? Because this little side of our orange one will rotate 90 degrees and fit into that little side of the pink one. And then the bigger side will kind of follow along. It will also rotate in 90 degrees and fit into that pink piece. And so now once we have all that, right, now we've done two 90-degree rotations, that counts as 180. And so at the end of that pink line, that's where I should put my next dot. Because this blue original dot that we were working with after two 90-degree rotations would now end up at the end of the pink line. And so that's where we want to put our dot for that. All right, and so that was a 180-degree rotation of that one point. And so now let's clean this up again, and let's pick a new point to start doing a 90-degree rotation from. So now I'm going to pick the blue point that's real close to Q. I only have to go up 1 over 1 to get to that point. And so now I want to think about doing my first 90-degree rotation and how if I turn this thing 90 degrees, that green line will match up with where I am drawing this orange line, right? The straight up and down piece of the green line will rotate down and now be the side-to-side piece of the orange. And then the side-to-side piece of the green will follow that along and become the up and down piece of the orange, right? And so there is one 90-degree rotation. And now we will perform that again, but now we got to rotate the orange 190 degrees. And so when I rotate that 190 degrees, that would fall on top of the pink one, right? The side-to-side orange would flip up and down onto the pink spot if it turned 90 degrees. And then the up and down part of the orange would flip right onto or rotate right onto the side-to-side little piece of the pink. And so now we've done two of them again. We've done an orange rotation and a pink rotation. And so after 290 degrees, again, that is 180, just like we're trying to get. And so we can put a dot on the end of that. And so I can clean that up. And now we've got 2 of the 5 points done. We took this first point and rotated it to here. And then we just took this second point and rotated it 180 degrees to there. And so let's do another one. I'm going to connect this one way over here now. And so that is 1, 2, 3, 4, 5 units away to the side and 1 unit up. And so now we want to think about rotating this one, and we got to keep going, and we want to rotate it in the same direction we've been going. And so if I rotate this one 90 degrees, it will go from being 5 straight side to side to now being 5 units up. And then the little top piece, just the 1 unit thing, will go over 1 unit from there. So again, what you want to try to imagine is, and I'll clean up this arrow, we were 5 horizontal, but then when we rotate this one 90 degrees, now that part just sticks itself up, and then the top like 1 unit lid, or whatever you want to call it, kind of goes and follows along, and it is now 1 unit side to side at the top of this line. And so then we want to think about doing this rotation one more time. And so if I rotate this thing back down 90 degrees for our second 90 degree rotation, it would go into this spot right here, right? The 5 that was going straight up and down on the orange would rotate down to become straight side to side on the pink, and that little 1 unit piece up there would follow it, and it would be going 1 unit straight down. And again, once we do the 90 degree rotation twice, we're able to put a dot at the end of our pink rotation. And so then we can clean that up, and that will be where this dot right here goes to on a 180 degree rotation. Now, this is all kind of complicated. I hope it's making sense so far, but we can kind of shortcut the process now. I would say we don't have to really think about rotating the other 2 dots in the same way that we just rotated these 3, because here's what I want you to notice. Once we did these 3, take a look at this side of our original figure. There is only 3 units between these 2 dots, right? 3 units. And it is 3 units, this dot right here is 3 units above the one we just rotated. So this dot up here in the top right corner is 3 units above the one we just rotated. But as you can see, as we are rotating this thing 180 degrees, it's bringing it a little bit further left, but it's also kind of like flipping it upside down. And so on our rotation, since that dot was 3 units above originally, it's going to end up 3 units below now, right? Just 3 units below. And so I can find that dot I just rotated, count down 3, and that next one should end up 3 units below it. And same thing is happening with our very final dot. It is 3 units above the second one we rotated. And so as it rotates 180 degrees, it's going to wind up 3 units below the second one we rotated. And so we can just put a dot 3 units below that one. And now that we have done that with the last 2 dots, we now have all 5 of them in place. And so if we connect all these dots here, you'll see it looks exactly like our shape up there, but it's been rotated 180 degrees around point Q. And maybe I should even put the upside down D in this shape, right? And that would be exactly what it'll look like. All right, that's going to be the end of this video. I hope that helps. Please let me know if you have any more questions about rotating. Go ahead and try B on your own. Notice you just have to rotate it 90 degrees and clockwise. And so that's the direction of the arrows that we've drawn there. All right, thank you very much.